So given this molecule, you're asked to find the hybridizations on these atoms and some certain bond angles. Now, if we're going to look at those hybridizations, we're going to look at how many sigma bonds and pi bonds this molecule has, and we're also going to look at if there's resonance on certain atoms. Now let's start off with carbon 1. Well, in carbon 1 we have 2 sigma bonds to a nitrogen and a carbon, and we know it's bonded to also 2 other hydrogens. So this, since it has 4 sigma bonds, it's sp3 hybridized. Now, what about this carbon 3? Let's skip nitrogen and oxygen for now. We have a double bond with oxygen, and then a sigma bond on another carbon, and a sigma bond on nitrogen. So this is sp2. Now, with oxygen, we know that it has 2 lone pairs and a double bond, so it should be sp2 given that it has 3 electron regions. Now, one thing to notice about nitrogen is that it does have a lone pair here. Now, initially, we would like to say that this is sp3 hybridized because it has 3 sigma bonds and a lone pair. Now, however, there is an interesting thing that happens here. What does happen is that we have resonance. So this lone pair actually goes and forms a pi bond with carbon 3, and this pi bond with oxygen goes and becomes a lone pair in oxygen. So what we end up getting is this molecule right here with oxygen having 3 lone pairs, and so I won't even draw them. I'll have a negative charge, and we'll have a double bond with nitrogen, and the other carbons will be unaffected, and so nitrogen will actually become positively charged. Now, if we try to do the hybridization on nitrogen, we notice that it has 3 sigma bonds and a pi bond, so it must be sp2. Now, we have sp3 in this situation, but we have sp2 in this situation. Also, for oxygen, it's sp2 in this situation, but it's sp3 in this situation because it has 3 lone pairs. So what do we pick? Well, we're going to pick the lowest hybridization. So if we're comparing sp3 to sp2, we're going to pick sp2. Now, if we have sp2 and sp3, we're going to pick sp2. Now, what does that mean? That means this nitrogen that we have over here, if we're going to look at it from a certain angle, it has that double bond there. It has this sigma bond come over here, and it's got that other sigma bond going back there, right? And it's trigonal planar. So now this nitrogen has 120 degrees along its 3 bonds. Now, what about that lone pair? Where does that reside? Well, there's actually an empty p orbital, because if you're sp2, by definition, you have an empty p orbital that's going to be perpendicular to that nitrogen. So if we assume, so say, if we looked at it this way, where we had the XYZ axis, and we had our nitrogen here, and it had its trigonal planar on the plane, it would be as if the lone pair is protruding back and forth outside perpendicular to that plane. Therefore, if we were going to actually ask what the bond angle was between the lone pair and that trigonal planar in sp2, so this lone pair, nitrogen, and that bond, if we were to ask what that angle was, it'd actually be 90 degrees because the p orbital is perpendicular to that trigonal planar plane. So we would say that the lone pair resides in the p orbital. Now, what about this oxygen over here? Well, the lone pair does not reside in no p orbital. It resides in the sp2 orbital that we have. And other carbons don't have any lone pairs in this situation. So if we were to actually look at the bond angle with this lone pair from the oxygen itself, and this carbon, well, it would just be the 120 degrees, just like as if we would ask between carbon 3, nitrogen, and the other carbon. It would also be 120 degrees. So, just marking some of these angles. So that's how it works when you get resonance on a nitrogen and it becomes sp2 hybridized, and they ask you for the angle on the lone pair. Well, the lone pair is going to be perpendicular to that sp2 plane, and so it's going to be 90 degrees. And so that's something very important to take into consideration when looking at the hybridizations of certain atoms in organic molecules. You have to make sure that there's resonance, and you have to consider this fact.